Quadratic systems with algebra 2. Solving quadratic systems are very similar to how we solved our algebraic systems, our linear systems, except we have two ways. We can either do it by substitution or by graphing. So there is no elimination method with this. All right, so let's look at the first one. Now, for these, I'm going to tell you which method to use, but on tests and quizzes, unless it is stated specifically to use a graphing calculator, the substitution method will work. If the directions state use your graphing calculator or use Desmos, you have to do it by graphing. So let's look at number 1. We have y equaling and then y equaling. So just like our substitution method before, we could put a box around 1 and plug it in for that variable in the other. So instead of y equals x plus 3, I'm now going to write everything in my box. So x squared plus 3x minus 5 equals x plus 3. Now here I have x squared, and I know in order to solve I need x squared to equal 0. X squared is positive on this side, so I'm going to move everything else over. So I'm going to subtract x, and here's a like term, so I can subtract x. I'm going to subtract 3, another like term, I'm going to subtract 3. So now I have x squared plus 2x minus 8 equals 0. Your best bet here is to then factor. Quadratic formula is going to take too long because we need to solve this. So I need to think what multiplies to negative 8 but adds to positive 2. In this case, we have positive 4 and negative 2. This is an easy factoring because nothing's in front. So it becomes x plus 4 times x minus 2 still equals to 0. Set each factor equal to 0. So x plus 4 equals 0 and x minus 2 equals 0. Solve for x on each one. So if I subtract 4 on the first one, I get x to equal negative 4. I'm just going to circle it so I have it for later. And I'm going to add 2 to the other one. And I'm going to get x to equal positive 2. And I'm just going to circle it so I have it. So now I know what x equals. X equals negative 4 and x equals positive 2. I need to figure out what y equals. Normally, we would take our numbers and plug them back into our box, but that's a lot of work. I also noticed that I have y by itself in the second one, and then just x plus 3. So I'm going to take each number and plug it back into this equation. You can pick the box, and you can plug it into the box. That's completely fine. I just like doing the easier problem. So we have to plug each one in. So the first one I'm going to do y equals, and I'm going to use negative 4, so negative 4 plus 3. Combine my terms, and I get y to equal negative 1. So I'm going to circle that. And then I need to do the same thing with 2. So again, I'm plugging it back into my highlighted one. Y equals 2 plus 3. So then y equals 5. Now here's the little tricky part. You have to remember which x value goes with which y value, because when we are dealing with our quadratics, our x squared, you're most likely going to have two solutions, and our solutions are our points. So, parentheses, when I had an x value of negative 4, comma, my y value was negative 1. So there is one solution. I can put a box around that. Then I also had x equaling 2, so parentheses 2, comma, when x was 2, y is equal to positive 5. And I can put a box around that. Those are my two answers. If you chose to graph, you could get that the same way, but I did want to show you the substitution method. Now, with number 2, I'm going to tell you right now we have to do this by graphing. So we are going to use Desmos. All right, so let me go to Desmos, and I'm going to type both in. So y equals negative 2x, and remember to get squared, you could hit this little keypad and hit the squared, or you could do Shift 6 on your computer, and also we'll bring you up to an exponent. So y equals negative 2x squared plus 3x plus 4. And then we can type in our second one, which is y equals x squared minus 8x minus 1. I'm going to hide my keypad so I can see both graphs. Now remember, solutions are where they intersect. I'm just going to zoom in. Here we have two solutions because they intersect two places. So the first intersection is a decimal, negative 0.409, comma 2.439. And our second intersection is at 4.076, comma negative 16.994. Decimals. Now, back to my paper. We did say when we were dealing with graphing, decimals are allowed. We just want to round to 2 decimal places. So 1 is going to be negative 0.41, comma 2.44. So there's one solution. My second solution is 4.08, comma, negative 16.99. And there's my second solution. So you can use graphing for either one, but if you are planning on going to college or a higher math, it is very, very important that you work on your math skills. So doing it by hand is also a great way to work on that. Let me know if you have any questions.